Over 23 episodes, we built every component of a production RAG system. Embeddings, vector databases, chunking, hybrid search, re-ranking, query transformation, evaluation, hallucination detection, caching, fine-tuning, parent-child chunking, streaming, agentic loops, and observability. In this episode, we wire them all together into one clean modular codebase. In part 2, we containerize it and deploy it. The project is split into 6 modules. Config handles all environment variables and settings in one place. Indexing handles document loading, chunking, and storing into Chroma. Retrieval builds the hybrid retriever with re-ranking. Generation handles the prompt template, the LLM call, and the hallucination guard. Cache holds the semantic cache class from episode 11. And the API module wires all of these into a FastAPI application. This separation means each module can be tested, swapped, or upgraded independently. The config module uses Pydantic settings to load all environment variables with type validation. Every tunable parameter from chunk size to cache threshold lives here rather than scattered across modules. Changing a parameter means editing one place. The settings object is imported by every other module. If a required variable like the OpenAI key is missing, Pydantic raises a clear validation error at startup rather than a cryptic runtime failure mid-query. The indexing module loads PDFs, splits them with a recursive splitter using settings from config, and stores the chunks in Chroma. The build index function accepts a list of PDF paths so you can index multiple documents in one call. Chunk size and overlap come from the settings object, so they can be changed without touching this file. The function returns the vector store object, which is passed to the retrieval module. The retrieval module builds the full hybrid retriever with re-ranking in one function. BM25 and dense retrievers are combined in an ensemble, then wrapped with the cohere re-ranker as a contextual compression retriever. The retriever K and re-ranker top-end values come from settings. The function returns a single retriever object that the generation module treats as a black box. Swapping hybrid search for a different strategy in future means changing only this file. The generation module exposes a single build chain function that accepts the retriever and returns a complete runnable chain. The system prompt follows the template from episode 5. Role, hard constraint, fallback phrase, and citation instruction. Because the chain is built by a function rather than defined at module level, it is easy to inject a different retriever or LLM in tests without changing any production code. The lifespan function calls build index with a list of PDF paths, passes the vector store to build retriever, and stores both the retriever and the semantic cache in the state dictionary. Everything happens once at server startup. Every request handler accesses state directly. Because each module is independent, swapping the indexing strategy means changing only indexing.py with no changes to the API layer. The streaming route calls build chain from the generation module passing the retriever from state, then returns a streaming response wrapping the SSE generator. The cache is passed into the generator, so it checks for a hit before invoking the chain and stores the completed answer after streaming finishes. The route itself is under 15 lines. All the complexity lives in the modules it delegates to, which is exactly how a maintainable production codebase should look. The application is complete. A clean 6-module codebase that wires hybrid search, re-ranking, semantic caching, hallucination detection, streaming, and LangSmith tracing into a single FastAPI service. In part 2, we write a Docker file, set up a Docker Compose stack with Chroma as a persistent service, configure Nginx as a reverse proxy, and deploy the whole thing to a cloud server. Subscribe so you do not miss it. See you in the next one.